I want to look today at hybridization in organic chemistry. And what we're really looking at is how many groups are around the atom that we're interested in. We can have 4 groups, and this will give us sp3 hybridization with bond angles approximating 109.5 degrees depending on the relative size of our 4 groups. We could also have 3 groups around an atom, giving us sp2 hybridization and a bond angle approximating 120 degrees, again depending on the relative size of the 3 groups. Finally, it's possible that we have 2 groups around our atom, and that would give us a hybridization of sp with a bond angle of 180 degrees. We can talk about the shapes of these 4 different types of hybridization and geometry, in which case the sp3 molecules would be tetrahedral at the sp3 center, they'd be trigonal planar at an sp2 center, and they'd be sp at a linear center. Or vice versa, I should say, tetrahedral at sp3, trigonal planar at sp2, and linear at sp. Couple of things that we want to remember. First, any sigma bond or lone pair counts as a group around an atom. Next, a double bond, which is made of 1 sigma and 1 pi bond, counts as one group. So even though there are 2 pairs of electrons making up the double bond counts as one group. And similarly, a triple bond counts as one group. So keeping these things in mind, let's look at some examples and try to determine their hybridization. Let's start with this molecule. And I think it's important for us to keep in mind what the line angle symbolism refers to. So when we draw something like this, it equals and represents something like this. And what I want you to see about this molecule is that all of the carbons in this molecule have 4 groups around them. So this terminal carbon right here has 3 other hydrogens on it. It has another carbon. It has 4 groups around it. It is sp3 hybridized. This carbon right here which is this carbon right here, has 1 other hydrogen on it. It has 4 groups around it. It's sp3 hybridized. All of the atoms in this molecule are sp3 hybridized. Since they're all sp3 hybridized, they're all tetrahedral, and they're all 109.5. I want to look at this molecule next. And again, I want us to remember what this line angle symbolism means. Again, we fill all our valences, so everything has an octet is what I'm referring to. So this on the end is CH3, CH2, CH2. This carbon is double bonded to the oxygen, 1 bond on each side. It has no hydrogens, and we don't want to forget the lone pairs on the oxygen. Even though they're not shown, they're there. So if we look at the hybridization of some of the atoms in this molecule, if we focus on this carbon, what we see is that it has 1, 2, 3 groups around it. Remember, a double bond counts as one group, so it is sp2 hybridized, approximately 128 degree bond angle, trigonal planar. Now, there are some textbooks and some people that say you shouldn't talk about the hybridization of a terminal atom, and I happen to disagree with that for some reasons I don't want to get into right now. So if you do consider an atom like oxygen and look for hybridization around it, even though it is a terminal atom, again, it has 3 groups around it because it has a double bond, which counts as a single group, and 2 lone pairs. So again, 3 groups, sp2, trigonal planar. All of the other atoms in this molecule have 4 groups around them, so they're all going to be sp3 hybridized. The next molecule I want to look at is this one, and this one in the line angle formula represents this if we draw it more explicitly. And what I want you to notice is that all of these atoms are sp3 hybridized except for the one that I put a positive charge on. What you'll notice is that the one with a positive charge only has 1 hydrogen. If we look at the one right next to it, it has 2 hydrogens. That's what that positive charge is telling me. That's how a carbon atom like this one becomes positively charged. It has 1 less bond than it's supposed to. And in the line angle formalism, we always assume any missing bonds are hydrogens, or any bonds that are not shown are hydrogens. This has 2 hydrogens that are not shown. This has 1. Since this only has 3 groups around it, it's 120 degrees trigonal planar. All the other atoms in this molecule are sp3 hybridized. The next molecule that I want to look at is this one. It's a little bit more complicated, and again, if we write what our line angle structure represents, it represents this structure right here. You'll notice that the carbons that have double bond between them, they each in this drawing have 1 extra H because they only have 3 bonds shown here. We assume any missing bonds are hydrogens. So both of these have 3 groups around them, a hydrogen for this carbon, another carbon, and a double bonded carbon, and likewise hydrogen, carbon, and a nitrogen for this carbon. They're both sp2 hybridized. I also want you to notice that this nitrogen has 1 lone pair, and this oxygen has 1 lone pair. Now, the nitrogen has 1 lone pair because we give all atoms an octet in this line angle formalism, and that gives us the lone pair we normally find on nitrogen. That makes that nitrogen sp3 hybridized. I also want you to notice that this oxygen with its lone pair becomes sp3 hybridized because it has 4 groups around it, and the reason that we put that lone pair on the oxygen is because in this line angle formalism, again, we give atoms an octet with 1 exception. You'll notice the only thing we haven't drawn an octet of valence electrons around is this carbocation. This carbon becomes positive by missing 1 of its bonds, whereas the oxygen becomes positive because it uses 1 of its lone pairs, it normally has 2, to form another bond. So this oxygen is also sp3 hybridized. The last molecule I want to look at is this carbocation, and I want to focus on the carbon that has a carbanion, a carbon with a negative charge. I want to focus on this carbanion because the way that this carbanion has its negative charge is by having a lone pair here. So while this carbon right here has 2 hydrogens that are not shown, this carbon with a negative charge has 1 hydrogen and a lone pair. Because it has 4 groups around it, this hydrogen, this carbon over here, this carbon over here, and the lone pair, it is sp3 hybridized. And in fact, all of the carbons in this molecule are sp3 hybridized.